Morning. Yesterday we looked at data frames and how to bring in your own data sets into R, and we did just one plot. Now today we are going to go further and we'll cover more advanced plots and we'll cover something very important, which is layers in Arrow, creating layers. So to create a new Arrow script, you can do Control Shift N. That will create a new script for you instantly. If you want to create it manually, you click on this, then you see Arrow script. So shortcut is Control Shift N. I'm just going to clean all of these ones out. Just create the new script. We have. Alright, so today's class is data visualization in Arrow. That's our topic. That's the topic for today, data visualization. Today is Tuesday, moving fast, I like it. Now, to visualize data, you need data, right? You need data in order to visualize the data. So what's this saying? Are you, let me see, are you sure you want to remove all objects from the environment? This operation, I say yes. Something is wrong. Are you sure? Did you execute any file?
Oh, yes.
Place the new file again, Control Shift N, then clear this and I think something was wrong here. I don't know. I have no idea what it was, but this is gone. Okay, so data visualization in R. Let's go. So remember that the first thing we do, step one, is to import the data set, right? Step one is to import the data set and make that a comment. So to import the data set, we'll repeat the same process we did yesterday, just so that you have a refresher. So our data frame name is df, and that will be equal to read.csv. Then inside there, we'll pass in file.choose. So this is the function we are using, file.choose. And once you execute this line, remember a window will pop up somewhere. This is mine. It will pop up somewhere. Make sure you check your terminal or something. Good morning. Why are you late? That's that command C. That is command here. File.choose. There, read CSV. And inside file.choose. So today we will be using the second data set. Or should we continue with the previous one? Which of the data sets should we use? The previous or continue with the first one? The new one. Okay, that's the movie's rating. All right. Yes, we're just starting. Waited for you guys. If you want to finish. The other set, those people used to see by 11, the certificate is out. Those people used to see by 11 o'clock, certificate is out. And you see, you are coming late. Oh, voila. We'll be here. And imagine, those people were just how many, when you met them, they were how many months ahead of you? It's not just 2 months. Certificate is out. All of them that took the exam. Okay, so if you have your window open, browse to where you kept, yes, where you kept the file, the movie ratings file. Mine is on my desktop, so okay, so I'll just go to my desktop and this PC desktop. I should find it. Yeah, movies rating. Yes, that's all. Click on it and open. And that's all you have to do. So now there are two ways. If you click on the metric object, it displays the entire data frame. Or if you call the name of the data frame now, to display the values here. But because of the way Arrow prints its values, I find it not very useful to come and to say data, call the name of data frame out here, because it's just going to print the values and it's not arranged like what we have in Python. So the best to view the data frame is to click on this icon and have it displayed, which is what I'm going to do now. All right, so when I click on it and I see my data frame. So we have the title, the film titles, all of them. We have their genre. We have their Rotten Tomato rating. You know that website, Rotten Tomato. Only if you don't know Rotten Tomato, and watching movies. How do you used to decide which one is good to watch? If it's not IMDb or Rotten Tomato, that's where you look at movies with the best ratings, IMDb and Rotten Tomato. So we have the Rotten Tomato rating, the audience rating, the film's budget in millions, and the year it was released. So we are going to do a simple analysis in Arrow with the data. How about yours? Still coming, please. While yours is coming up, we'll be moving forward slowly and steadily. All right, now our data frame has been created. Let's rename the columns. So step number 2 is to rename those columns. You know, the reason why we are doing the renaming is you notice that Arrow doesn't allow empty spaces between column names. It will fill it with dots. So you can see that in this column, we have rotten dot, tomatoes dot, ratings dot dot. All of that. We want to get rid of all of this ugliness. So for that, we will rename the columns. And so we'll say column names. Remember the function column names for the data frame called df, and that would be equal to a combine where we will define. So since we have how many columns, if we to check the number of columns, what quick quiz to check the number of columns, what's the function? N code. for this data frame. We have 6 columns. To check the number of rows, you do n rows, please. And we have 562 rows and 6 columns. So for that, we know that we will have 6 column names inside of the combine. So the first column, we'll leave it as film, but I want them to be in lower cases. Second column, we'll leave it as genre, but I want mine in lower case. The third one, we have to name them accordingly so that we don't mix it up. So film, genre, this is Rotten Tomato rating and audience rating. So this one of Rotten Tomato rating, I will just use, what I will do is I will say critic rating, because that's what it's all about. So I'm using underscore to split it. And for the audience rating, I'll leave it as audience. In fact, I want this to be one word, so this will just be critic. I just want one word columns. And this would be, next one will be budget. And the last column will be year. So with all that, I have renamed the columns. So we have new columns now. Not necessarily new column, but at least we have new column names. So if we look at this has updated. So good morning. Leon, where are you? Hmm? Okay. Now let's talk about, yes, new notebook, new script. Let's talk about aesthetics. In yesterday's notebook, there was something I used, AES, this method, or this function rather. Let's see if we can find anything for this. Okay, no information. Problem. So the library we are using for visualization is ggplot, the one we all installed. So you've installed ggplot, have you? Okay, so everybody has installed it. And that's the library we'll be using for visualization. Now there are two ways to activate it. The first way is we can say library, then you call the name of the library you want, ggplot2, and you run this. That's method number one. Method number two, which you might find easier, is this. Ison, look at the screen. Go to your packages, open the package window, then inside there, search for the library you want, which in this case is ggplot, and simply turn it on. So the two methods, method number one is you execute this line where you say library and you call the name of the package you want to activate inside here. So watch what will happen. If I execute this cell, you will see a check. This box will be checked. So just watch. I'm going to execute it now, and see the box just turned on. So if I deactivate this, it says detached package ggplot2 on load equal true. So both of them do the same thing. If I just click on this box, this same command, library ggplot2, will be printed in the console. So watch now. So you see it, library ggplot2 appears in the console. Both of them do exactly the same thing, but for the sake of convenience, everybody prefers doing one click, off, on, off, on. All right, so just make sure ggplot is on. That's the most important thing. You'll go to your packages and make sure it is on. So if it's turned on, we want to start using it to plot our chart. So we'll say ggplot. Yes, that's what it does. It's only for graphs. So we'll say ggplot, and then we specify the data frame we want. So we'll say data will be equal to the name of your data frame, which in this case is df. And then we will pass in the AES function. So look at what it says here, that this constructs aesthetics mapping. Aesthetics mapping describes how variables in the data are mapped. Visual properties, aesthetics of geoms. These geoms is a keyword, or explain what it means soon. What did you call it? Exactly, geometry means shapes. Yes. So it is the way how to use manages to build shapes. So those shapes represent the chart. That's the way it's going to work. So you pass in your x and your y and any other arguments you want to pass in. So when we say aesthetics, we'll put it in a bracket. Then we'll say our x should be maybe, if you're comparing the audience rating against the critic rating, our x can be critic rating and our y can be the audience rating. Then we can use other properties like the shape and the color. So I'll show you the difference between mapping and setting. There are two distinct um, concepts in R. Any other in Python, it wasn't that difficult to explain because we know we are using the keyword hue, right? But here, mapping and setting are quite different, but I'll explain what they are. So just know that this is the way you use it. You call on ggplot, specify your data to be the data frame you want to work on, and then you use the aesthetic function, which is what allows you to pass in your x, your y, and your other variables. So we will replicate it as it is. So aesthetics. So we say that our x is equal to, now we don't need the quotation mark. We don't need it. So let's take x to be critic, comma, y to be audience. Cool. So if I execute this as it is, this line, what happens is that in our plot window, it opens up, but there is nothing. It will be empty. The moment you declare only x and y, it is going to be empty. And there's a reason why it would be so. Because of the last feature. Sophia, are you done? Where are you? Have you successfully changed your column names? Check, click on this, check the metrics object. It's going to update. If it changed, it will update here. If there are no errors in your console, then it's worked. So confirm that. Now, let me see what I'm talking about. No, this is it. Supposed to stop this which is on here. Okay. So it's updated country. This is not the data frame. So run it again. Movies rates me up for working list. Then number of columns, it's correct. Number of rows is 5, correct. Once we update this, errors, letting string, strength string, columns. Here, this one is 1, 2, 3, 4, 5. It's supposed to be 6, right? Didn't change. Why is that? Budget. There's no common here. The comma, error in columns. So here is supposed to close this. Close it. Remove this last bracket. Remove this last one. Alright, so now updated. Okay, so I was explaining that if you execute this current line, all you will get is your plot window will be activated, but there will be nothing in it, to be empty. Why? Because you have not specified any geometry. You get? So remember in the syntax it says you have to specify a geometry. So that geometry has not been specified. So if we say ggplot should take that this is where the data is coming from this data frame, and the x value is, say, the critic, and the y value is the audience, and that's all. It will say, fine, I can do this, but how do you want me to represent this? So what you do now is that you say that you do a plus, if you type this keyword geom, you will see different objects. You see points, which means it's going to create small points, like a scatter plot. You will see line, which is going to create a line geometry. You will see box. You will see this is just the keyword you need. Geom underscore. No, it's going to be outside. Wait, I'll show you. Professional analysis. I'll share to use it. So all you're saying is that based on this condition, use the geometry I will specify. So if you say point geom underscore, once you do geom underscore, you will see a list of geometries you can use. So you can say point for scatter plot, line for line chart, and there's one called the smooth. I like this one. I prefer it to the line because it's smooth. It's line, but it doesn't have those sharp edges. It shows the curve, the trend of the data, but it's not like this. So that's why I like the smooth. So all you need to know is that you're going to say geom underscore, then you pick the geometry you want. But this plus sign has to be there at the end. The plus sign must be there. So at the end, after you've declared this, after you say that ggplot should take your data frame and use this for the aesthetics, then you will include plus the geometry. That's the way it's going to work. If you don't give it a geometry, it's not going to print anything. So now we'll say plus geom. So you can see all of these you're seeing there are types of charts that it can build. Area chart, bar chart. Most of them, this is a count plot. Most of them I've not even used before. They are plenty. So geom underscore. Because remember when we talked about charts in Python, we say that when you're comparing two numeric values, the best type of chart to go with is a line chart or a scatter plot. So because of that, I will use the point. So geom underscore point. And there are some arguments we can take inside here. I'll show you that later. But for now, just execute this. And now you should have if you click on the zoom, it opens your chart in a brand new window. Yes, very helpful. Opens your chart in a brand new window. And now we can see that That is struggling. Plot. Where is nothing coming up? Hmm, library. That's it. Not sure why it's not coming up here. Something is activated. So we can comment this out. Yes. Until you include the plus geo underscore points, then what's yours doing? You're just trying different thing. Points, points, or scatter plot. Ew! That is very fine. What am I using? Density. Hmm. Data analysis in R. Add it to your CV. Let me see. No, it's supposed to close. It's supposed to close. Like it's a method. It has to be closed. Mm-hmm. Okay, so okay, you are getting ahead of yourself now. All right. So there's a very clear um, linear regression because I believe it's a strong relationship between the critic rating and the audience rating. So as you can see that despite the genre of the movie, as the critic rating is increasing, so is the audience rating. So you can tell that if the critic rating is high, the audience rating is most likely to be high. If the critic rating is low, audience rating is most likely going to be low. So critic, we change the column of Rotten Tomato to critics because that's is a Rotten Tomato is a website where people go to criticize movies. So if the critic rating is high, the audience, the people that maybe went to a cinema to watch the movie and gave their review to will most likely be high. That's what we're seeing here. Now let's look at adding other things because Ado will give you this black point like this, no matter what you do, it's just going to be black until you decide that you want to add something. So this year we'll talk about mapping versus setting. So this is where we'll talk about mapping. So for this one, please, you need a note. Mapping versus setting. So in mapping, this is the major difference. In mapping, we use one feature in the data set to create a visual distinction from our comparison. Meanwhile, setting, when we are doing a setting, we are just defining a physical or visual attribute to the chart. Now, this is where they differ. If we say after we've done the X to be the critic and we've done the Y to be the audience. Now we can map, if we say that, let's say the hue, for instance, if we take the hue, which is not the word, we can say color. Okay, let me stick with Arrow's interpretation. If I say that color should be equal to, give me one column there. No, we have already used critic and audience. So give me a third attribute. Budget. Color by budget. Color by budget. Budget is numeric, so let's use size. Let's use size. So if we say that the size is the budget, we are taking the numeric value from budget to set. So what will happen is that, yes. So what's going to happen is that as those dots, as these points are spread across the data set, the movies with the bigger budget will have the bigger size. That's the mapping. You are mapping them according to their size. So maybe if the movies that have the best rating are the movies that are having the biggest budget, we'll now start seeing bigger dots here because they have larger size. But if the movies are having the worst ratings and movies are having small budget, we'll start seeing tiny dots at the bottom. That is mapping. But in terms of setting, if we say the size should be, let's say, 50 pixels, all the size will be equal. It's just like saying maybe the dots are too small, we want to enlarge it. So if we set the size to be 50 pixels, all of them will become 50 pixels. If we set the size to be yellow, all of them will become yellow. But if we set the size to also be something like the budget, maybe we set the color to be the budget, what will happen is that movies that have a unique number for their budget to have a unique color, that feature will now categorize them. So remember I said that when you're doing things like that when we're in Python, if the unique values are too much, you can't use it for something like that, because something like budget, every budget may differ, especially if it's by a decimal. It's just different, so the unique values will be too much. So the chart becomes too much to read. But we have general. There are only like how many generals? There cannot be more than 10. So it will be easy to set color to the general. So each point will have a unique color according to the general. But we can use their size. We can use budget for size so that we know that the bigger dots have the bigger budgets. That is mapping. But setting is when we are just defining it that let all the dots, all the points be 10 pixels, 20 pixels, 50 pixels. We are setting a size. When we are setting a color, we are saying the color should be yellow. That is setting. The color should be green. That's setting. And what we did yesterday, which color did we use for the chart? The one we did yesterday. Color was what? Check your income. That is mapping. That's an example of mapping. And even we say the color should just be blue, that is, we set a color for it. That's the difference between mapping and setting. Mapping comes from a feature in the data set. Setting, we're just defining the physical property, the size, the things like the, what do you call, transparency, right? maybe want them to be a little bit transparent, you are setting those values. For mapping, we are deriving those values from data sets from a feature. That's the core difference between mapping and setting. All right. Now, let's move. There's my house studio. Okay. So since we've cleared the air on mapping and setting, let's look at adding colors. So what I will do is I'll copy the same thing just to save time, and I'll paste it here. So this time around, if I do this, if I say that the color should be equal to green, what's the issue? Okay. Unexpected string. Okay. Okay. Let me hold on. Okay. That's not green. That's nothing like green. Alright. Still it's not catching the color. No problem. I'll try to do something. So what we'll do is I'll set the color to be color. I'll use the general for color. So I'll set my this color, spell it as COL. Use this spelling. Yes, and I'll set it to be this general, and I will execute. And now you see that we have different colors, and each genre is representing a distinct color. So okay, now you can take this on that line as long as you highlight and execute all of them together. Oops, not working like that. The next thing I added was this, so it should be fine. Saying color is equal to general. And you can also set the size, map the size rather, to budget. So you can map the size to budget and come in. Now you should notice that oh, so while we are looking at the individual colors representing each genre, the size is representing, we are using the size, the value from the size column to drive the size of the data points. So the movies with the best ratings are the biggest budget also. Obviously, if they're coming from thriller, then we can see comedy, drama, and the rest. So let me go back to the code. So if you're having an issue here, if you have fixed it, okay. Okay, so let's see if we are done something else like this line. We are changing it to a line. Okay, so the issue is now the size. I'll get rid of the size. Don't change yours. Don't change yours. I'm just doing it. So I'll show you how it works. So this is a line chart. You can see how scattered it is. But then, like I said, there is a method called the smooth, which I like. Smooth. This one. It's going to give you nice curves. So this is what is giving me. This I prefer to the regular line. I prefer this one a lot. Yes, same argument. I just changed from line to smooth, but I'm not using the size anymore. The next thing I changed was this. Okay, you're getting it. I don't know if I'm changing it, I say don't change it. Alright, let's do something interesting. Depending on the data, remember that the plot would work depending on what you're comparing the data. Now, let's look at layers. Plotting with layers. Now, this is where arrow becomes a little bit tricky. So, remember that to plot, we have to do, at the end of that thing, we have to do plus geometry be whatever we want it to be. So what if we want to do a scatter plot, a line plot on the same data? How do we go about that? The easiest way to do it is to create a variable name. So let's say we have a variable name. Now this variable name can be your whole argument, right? So you have your ggplot, everything. Save it in a variable name. What you will now do is, so you can now simply say your variable name plus because this variable name holds all of these arguments. By calling the variable name plus this, it will give you a line plot. By calling your variable name plus, it will give you a scatter plot. I don't know if it's clear enough. So that's what we do with layers. Using layers allow you to create plots faster from the same selection, instead of typing and copying and pasting. So what we will do now is to create our own plot faster and do different comparisons. So now we are looking at layers, and to create the layer we need a variable name. So let's call this one x, and x will be equal to all of these arguments except the plus. So we just do this. This is what x is equal to. So inside here, color is equals to general. Now add the size again. Size, add the size, let the size be equals to budget. So make sure you run this line and define that x variable and confirm that it exists in your chart, in your environment. Very important. Confirm that it exists in your environment. So once you have it, you can now simply say x plus geom underscore yes, remove it. You don't need it again. So now we can simply say point, and it will give you your desired, plot. And you can simply go to another line and say x plus geom underscore smooth, and it will still give you your desired plot. So you see, using the variables, it makes it easy and fast to reuse your selection. So what happens if we want to do a scatter plot with a line? So here we look at using multiple layers. So that will be x plus geom underscore point plus geom underscore smooth. So since we have done this, what we will do is going to create a scatter plot alongside a line. It will give you the warning because it can't apply the size to be smooth, but nevertheless it's going to work. So this is applying multiple, this is how you apply multiple layers right here. The most important thing is make sure your x has been created, that variable name is created. So here you can do it one at a time, or you can combine plots. That is the most important thing I wanted you to see. Any challenge? What's the issue? What's the matter? You've not created that text. There's no text here. Here, there's no text. You did not run this line. Then, let me see. Yes, you have to remove it because you don't need it again.
In all of them.
Oops.
Just,
Yes, yes. Then you've not closed this. Once it's not closed, it's equal to budget. How is budget having? No, you've got no. This is wrong. Data is equal to data frame. The aesthetics. This should go. You don't need strong. This one has to go. It won't even be there in the first place. Then all of these arguments will be inside here. Then once if you remove this and this is all you need. Then x has been created. So x plus g1 that plus 2 points will give you a scatter plot. Now there's something wrong with that. Let's see. Creative y equals audience. Follow is equals to generous is equals to x plus g1 underscore points. This is budget not found. So budget. What's the spelling of your budget inside here? BUDJ, it's that there is coming from. That is working. So you would go back to here. Yes, make this G and make this one G. That's all you have. Just control A. You don't need to reinforce the file.
so let it run it. Not not problem.
Here's what your budget is not found. Do this again. Just this. As subjected. So budget. Okay. Still your bit is slow. Ignore a bit. Then this one should this one should. Okay. So have we done this other line, the last line? Felipe, Alpha, you done? Okay. So let's look at a concept of overriding aesthetics. Overriding aesthetics. Now, the reason why we are doing this is look at this error or the warning message that is telling us that it cannot apply size to this smooth. Are you seeing that warning? You have the warning. Good. So in the case where you've already defined what you want, you also what's going on. You still have the option to override. Remember, this is the aesthetics as you've defined it. Everything inside here is the aesthetics as you've defined it. But you still have the option to override the aesthetics while you're printing your chart. Now, if I say X plus June underscore, let's say smooth in this case, smooth. Now I know that size cannot be, it cannot apply size to that aesthetic, to that chart. So what I can do is to say that size should be equal to say 2. So let me try this. All right. So what I've done now, this is a case of setting, not mapping. I simply set the size of the lines to 2. And you see that it's not giving me any errors this time around. There are no errors, no warning message, no errors. So reducing the line size to 1, reducing the line size to 0.5. So now the lines are tinier. Now I can go ahead and still add the points behind it and execute. Are you seeing there are no warnings this time around? No warnings, everything is fine. So let me see what I have done. All right. Now this is a whole lot better. It's 10 times prettier. So that's how you override aesthetics. And one thing I need you to understand is all of the aesthetics that you've defined inside of here, inside your initial argument, you can override it. You can override it here, 100%. The size, the color, whatever aesthetics you've done, you can override it. Now, another method you can use in overriding aesthetics, you can simply say that the same X and same X plus June underscore, let's take points, and then we can say that the aesthetics I need one more here. So inside here, I can now say color, COLOUR. Color should be that column name was what? Budget. So all right. Now values with the highest budget have the darker colors. I think so. I think that's what is happening here. Or smaller budgets have the darker values. Rather, look at the color range. The larger budgets have the lighter blue. So the aesthetics can be overwritten anyhow you want it. You can set and you can map your aesthetics anyhow you want it. But while you're using it, just be careful. I will save that image. Where am I saving it? Save to my desktop. So yes, if you want to save, click on export. I want to save the one that has errors. So you can click on export. You have save as PDF, save as image. You can save as image. And you can give it any name. Choose the directory you want to save it to. Mine, I'm saving to my desktop. And click on save. That's all. Let me try the color again. Last time I did the color, it didn't work. Let me try setting the color. Still not work. Why is it not canceling? Hold on. Okay, I think I got it. Oh, it's too much. I'm just overriding it. I set the color to dark green. I don't know why it didn't work inside the original plot, but it's working out here. I can override the colors here. Here, inside this overriding section. Yeah, it didn't work at all. 1235. Okay, now let's look at our other types of plots we can do. There are many of them, but we'll just cover a few. histograms and bar charts. All right, now before we start typing the code, let's remember a little bit on the intuition part. When we want to do histogram, bar chart, what data types are we comparing? Hmm? When you are building histograms, bar charts, count plots, what are we comparing? Sophia the analyst. Forgotten. Wow. All those talk on statistics, all those things we are doing, I've forgotten. Not fair. If we want to look at frequency distribution, which plot we use? To look at how often something has occurred, frequency distribution, which plot are we using? Which one you know? What is this saying? Remove it. Yes, remove it. Remove the brackets. Okay, fine. Let's move on. If we are looking at frequency distribution, it's of course a histogram. And under frequency distribution, how many shapes do we have? This is what a histogram will look like. Of course, you know. Histogram. Histogram. Very important. Anyway, let's we don't have much time. Let's finish. Let's get done with this so that by tomorrow we'll start machine learning. It's Aaron. All right, histogram and density chart. So let's create new variables. Let's say S is equal to ggplot, where your data, so share you with us. You're not with us. I'm seeing here. Data is equal to df. The aesthetics, we need 2 columns. So we'll set the x to be our budget. Then when I can now say S, I have not executed this, so this does not exist. All right. So x plus geom underscore histogram. So first, I won't add any any fancy to this. I'll just run this. All right. What can you tell? How do you read this chart? My analyst. Stop typing code. Come again. I did not hear you. I have zoomed in. Don't worry.
What are we?
Yes. It's for you to read. This is a histogram. You have to read the chart. When you look at this chart, what do you see? Uh, this has nothing to do with relationship. Zero. I'm going to draw the screen first for you see. Hey,
And what we are seeing.
open your notebook, go to frequency. Wait, go to frequency distribution shapes. Open your notebook. Go to frequency distribution shapes. You're not seeing it. You are drawn on the screen for people to see it. Oh, okay, that's not. Oh, okay. This is it. This is it. This is it. This is it.
Right. Okay.
This is positively skewed. Right skewed, left skewed, exactly. Here's the one for negative skewness. Don't write that one. The opposite of this one, where is it? When this is when, remember, according to Pearson Mute, this is positive skewness. Yes, where the tail goes to the right, it's positively skewed. It means that this is the mode, which is the highest occurring value. So your mean, so the mean is higher than the mode, right? Mean, median, and mode. So which one is here? According to that, this is the mean, this is the median, and this is the mode. So when the mean is higher than the median, and the median higher than the mode, is what? Negative. Is it negative or positive? This is what we are looking at now. That's positively skewed. The tail is going to be positive. So this is positively skewed. So it means that the bulk of our data, many of the movies, their budget is between 0 and 100. Only very few movies have 100 to 300, maybe 300 million in their budget. And you can see that these are the outliers. These are what these are the, yes, outliers. Extremely high values that are far from the distribution. Uh, let's continue. I'm looking for who wrote it. Not your handwriting. Told you, read your notebooks. Everything you need to know is inside that notebook. I took my time. That is not the first thing. It's not obvious. All right, let's add aesthetics to this. Let's add aesthetics to this. So we have the histogram. What we can do now is to add some aesthetics. Let's see. First of all, the number of bins. And here the argument is bin width. Remember 10. Have you here? Have you done this? Did you run it? Do you have S in your variable environment? Did you do S plus this? No. I say you're not with us. So then we create the aesthetics and we set the fill. Now, remember mapping and setting. For this, we can set the fill to be a color, or we can map it. So we can map it based on the categorical feature, which if you remember here, we have genre as our categorical feature that we can always rely on. So we can set the fill to be, forgive my casing, fill to be genre. Okay, so missing this. So something is doing something wrong. Bin width equal to 10. This extra, this is being extra. Alright, we are fine here. But we set the, hold on. Hold on. If you are setting the fill, not file. Aha. Thank you. I was wondering why. Okay, now it's not working. So you don't need this. You don't need this. Now something is wrong. Okay, so 2 here and 1. Alright. So this should work now. And what am I missing? S plus geom underscore histogram. Bin width equal to 10 is correct. The aesthetics fill is with, I guess I'm not spelling that genre properly. Genre. Genre. That's correct. Yours what? You two on what? So why? Okay, mine just picked. So add one more argument. Add color to black. Now the reason why I want to add the black is this. Let me show you why I'm doing that. If I zoom in, come on. All right. So the reason why I want to add the black is there is no gradient. Yeah, we can see categories, but it's looking somehow. So if we add the black, it will add the outline color. Since the fill color is the genre, it's filling the bars with the genre. So we need the outline color so that we can see the distinction clearly. So set the fill to black. What's the issue?
I'm not getting the error. Man. Not. After I did that, like
You've created the S, right? The variable.
okay. Okay, we did first before. That's right.
So here I would supposed to be S plus. That's true.
Why isn't this project?
No, we are doing layers. So you have to define your selection first. Then here you add the layer. S plus. This is the layer. You're defining the histogram. S plus the histogram. Remember, this is
But normally it's not fill out and
empty. No, but it will not because we did not call the variable name. So if I do this now, S, now what? If I just call only S now, then it will print without any, because we didn't call the variable name. No, initially when we are doing that, we consider using variable names. That's why so it's working. Yes, we set, every object has a fill color and the outline. So the outline is, let's say we have a square. The outline color is black by default because it is the border color. Then when any color I use inside is the fill color. Yes, that is the fill color. So since we say that the fill should be equal to genre, that's we're setting it, then, but now the problem is there is no outline color. So areas like this, there is no boundary, we cannot see any boundary. So we need to set the outline color. So by saying that the color should be equal to black, we now define the outline color for it. Once you do that, it will become 10 times beautiful. All right, now look at what it has become. What is the now? So this is the black we defined. So now that serves as your outline color. And again, I would love to save that image. So all these images are fine. Are very, very fine. I like them. Yes, color equals black. This black is what serves as the outline color. No, 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 no.
So you don't have
By default, okay, let's take out this, take this out. Let's answer that question with a practical approach. So if I execute just this is what you get. Yes. But yes, that's what it's going to look like. It's going to be ugly. All right, now let's look at. So we've already done density chart already. You've already done the density chart now. Yes, now I saw you doing it earlier. Gem_density. So if we do this, we have a, remember this is what your KD plot looks like. And I've explained it that a KD plot is very important because KD plot shows density. KD plot is your violin plot. Don't forget that your violin plot is just a symmetrical KD plot. Because if a KD plot displays like this, your violin plot will look like this. This is just a symmetrical kernel density estimator, which in fact in the name of the plot, kernel density estimator. So it shows you where you have high density and low density. So now, by just saying density, it creates your density curve. We can set the field now. We can set the field, and we can set the field to be budget. So since our X is budget, if we set the field to be budget, areas that have high values of a certain amount we will see the concentration there. If we set the field to be genre again, the most common genres would be, you'll see the distribution on that one. So let us play with the field a little bit. Let's go. So inside here, I will say aesthetics and field would be equal to, sorry, not plus, equal to, first I'll try budget. Okay. Warning message, the following aesthetics were dropped. Field, why was it dropped? Why was it dropped? This can happen ways to infer the current grouping structure. I spell it well. Budget. Okay. Let me try general. Looks to work. Numeric, so it doesn't take that. So work with this. Then one more argument is the position. I have. And this is my plot. Very, very beautiful, right? All right, that will be all for visualization. That will be all for visualization. Why what? It wasn't accepting the numeric value. So switch So that's all for visualization. Tomorrow we will start data machine learning with R. So hopefully we should cover that class between tomorrow and Thursday. Cover that. Yes, machine learning is the last thing we'll do for R. And hopefully tomorrow and next, even that,